In this case, we have to evaluate electric field. Okay, the situation is such that we have an atom, and we are dealing with the nucleus of an atom which contains 94 protons at the nucleus. Okay, we had to assume that the nucleus is a sphere with the radius 6.64 femtometers. And Fm stands for 10 to the power minus 15 meters. Okay, so we have to evaluate the electric field at the surface of the nucleus. So we are to assume the nucleus is a sphere, okay, a spherical body, okay, containing 94 protons, and the radius of the spherical body is R, is given to us as R equals 6.64 times 10 to the power minus 15 meters. That is the radius. So to evaluate electric field, we can easily see that since it is positively charged nucleus, the electric field is going to face out. So all our electric fields are going to be outward, since we have a positively charged field. So we have to evaluate the electric field at the surface, this surface. So the distance of the surface from the center of the nucleus is our R. So to evaluate the electric field, we use this expression which says that the electric field is going to be 4 phi epsilon naught R square. 4 phi epsilon naught R square. We are given the total charge, which is 94 of the charge of electrons. We know our distance, so when we put the values here, we have put 94 multiplied by 1.6 times 10 to the power minus 19, all divided by 4 phi epsilon naught, which we can easily say, okay, 9 times 10 to the power 9 to give us the 1 over 4 phi epsilon naught. Then we divide by the R square, which is 6.64 times 10 to the power minus 15, everything here square. We are going to end up with a value which is 3.07 times 10 to the power 21 Newton per coulomb. This is the intensity of the electric field at the surface of the nucleus. Very, very large value. Okay. Okay, here is another question relating the electric field. In this case, we have a charged particle which produces an electric field intensity of value 2 Newton per coulomb at a point which is 50 centimeters from the particle. The question is we have to find the magnitude of the charge. So from our relation that we have a charge, and this charge produces an electric field intensity here of magnitude 2 Newton per coulomb, and the distance between the charge and the point here is 50 centimeters. So the question is, what is the magnitude of the charge here? So we use our expression that electric field is equivalent to charge over 4 phi epsilon naught R square. So the charge is the one unknown. So we use the charge. We can now cross multiply to have the electric field, which is given to us 2 multiplied by 4 phi epsilon naught R square to get the charge. So when we plug in the values, here is going to be our 2, which is 2 newtons per coulomb, times this one, 4 phi epsilon naught, which is 4 phi times 8.85 times 10 to the power minus 12, times R square, which is 0.5 meter square. Okay, when you put in the values, you find the products here. We are going to get our total charge as 0.055 nano coulomb. Okay, around this value. Here is another question involving electric field. And in this case, we have three charged particles, and we are given the charges. That the particle here has a charge of plus charge on electron, and the particle here is also having a charge of electron, while the particle here has a charge of two positive, is like 2 protons here. And we have points here, a point here P, where we want to evaluate the resultant electric field due to these three charges. Okay, so if we can redraw the diagram so that we indicate okay, so here we have a positive charge E. Here is also a positive charge E, and here we have two positive charges. Here is our Q3, here is our Q1, here is our Q2. And the point here is a 6 micrometer, the distance given in the question, 6 micrometer. And from the diagram, it can easily be seen that this place is 90 degrees. And the point P here bisected this angle such that here is 45. So if here is 45, it can easily be seen that this place is also 90, is given that this place is 90, therefore here is also 45. So this angle is 45, this angle is 45, this angle is 45. It means that the distance from here to here is the same from here to here. Okay, the distance from here to here is the same. So here is also an isosceles triangle. So you can use Pythagoras theorem to find the hypotenuse here. The total hypotenuse here, which can be 6 square plus 6 square and square root. So our total distance, the hypotenuse here, can be square root of 6 square plus 6 square, 36 plus 36, which is here is 72, root of 72, which is equivalent to, okay, so it's this is 6 root 2, this is 6 root 2, such that the distance from here, from P to Q2, is going to be 3 root 2, and the distance from P to Q1 is also 3 root 2. So in terms of field, Q1 will create an electric field away from 8. Q2 will also create an electric field away from 8. Similarly, Q3 will also create electric field away from 8. So at this point P, in terms of field, this is what we are going to obtain at Phi. Okay, this is the electric field due to charge C. This is the electric field due to charge 2, and this is the electric field due to charge 1. And we can easily see that since E1 and E2 are equidistant with respect to the phi here, it means that the two fields of E1 and E2 will cancel each other. So our total field along this line will be 0. Okay, E1 will cancel E2 because they are equal and opposite. Equal and opposite, so they cancel. So E1 cancel is equals to negative E2. Therefore, when we add E1 plus E2 in terms of the vector, we are going to get a resultant of 0 vector, 0 vector. So the net electric field is only the E3 and is here in this direction. So let's evaluate E3. When we come here, E3 can be evaluated from charge 3 over 4 pi epsilon naught times the distance R3, which is this distance, R3. This is distance from here to here. And this distance from here to here, it is the same as this distance because this angle is 45, this angle is 45. It means this side and this side are the same, so it is our R3 is the same as this distance. The two protons, two protons here. Our R3 is the distance we have evaluated, which is equivalent to this 3 root 2 microfarad. So it's equivalent to this distance because that is the same distance here, that is the same distance here. Okay, so putting these values in, we are going to get 2e is going to be 2 times 10 to the power 2 times 1.6 times 10 to the power minus 19, which is 2e, times, instead of 1 over 4 pi epsilon, we can put 9 times 10 to the power 9 all over our r square here. But this r is square, so it's going to be 3 root 2 times 10 to the power minus 6 square of 1600 Newton per coulomb. So this is the electric field, the magnitude of our electric field. And the direction of this is along this line joining the P. So this is the direction of our electric field. So the direction, it is 45 degree from with respect to Q2 and also 45 degree with respect to Q1. So this is the net electric field we are due to at the point P. As we have seen, the electric field due to Q1 at P is pointing this way, and the electric field due to Q2 at P is also pointing this way. And since the point P is equidistant from Q1 and Q2, then the electric field intensity due to Q1 will be cancelled by the electric field intensity due to Q2. So there will be no net electric field intensity due to Q1 and Q2 at P. But our electric intensity due to Q3 is not balanced by anything, and therefore we are going to expect to have this non-zero electric field of value 1600 Newton per coulomb. Okay, thank you. Simple example of that involves electric field. It involves electric field, but in this case we are given a distant charge. Okay, we have a charge here, and the charge create an electric field of 4 Newton per coulomb at certain distance. So the question is, at what distance does this charge create an electric field of magnitude 4 Newton per coulomb? So let's assume the charge is here, and assume the distance r is here. Okay, we have to evaluate r. The electric field at this place is 4 newtons per coulomb. Okay, and our charge is 5 times 10 to the power minus 9 coulomb. That is a nano coulomb means 10 to the power minus 9. So if we are to write our expression for the electric field, we say electric field is the charge over 4 pi epsilon naught r square. Okay, and if we know our E, we know our charge, which is this. Our unknown is only r, so we make r the subject of the formula by cross multiplying, so that we have our E times 4 pi epsilon naught r square equals to our charge Q. This Q is here, and we're solving for r will give us r squared to be equals to the charge all over 4 pi epsilon naught e. Okay, so let's insert our values here. R squared is going to be, our charge is given 5 times 10 to the power minus 9. 145 epsilon naught is 9 times 10 to the power 9. All over our E is 4. When we evaluate this, when we evaluate the square root of this value, we are going to get 3.354 meter as the distance of the point from the charge.